Okay, the answer here is 1. Hopefully you got that. If not, ask me during class, and I will gladly go through it with you. Okay, moving on to a very important topic, geometric series. Pause and copy this definition and this theorem. So let me see. So a geometric series is anything of this form. Next one will be AR cubed, and then AR4, and a series. Goes on forever. And what I'm saying here is that you can write this in sigma notation 2 different ways. You can either use this way to do it, or you can do it this way, where your sum starts at 0. Okay, so this is a nice series in that we can find the actual sum. Okay, we can actually find the sum sometimes. Let's go right here. I use the word if with 2 F's. That is not a typo. Oh, what's going on here? Stop. Oh boy. Okay, I'm back. My if, not a typo. If is short form for if and only if. So back to my equation up here. So this series, infinite series, equals exactly this if R is between 1 and minus 1, strictly. Okay, that is what I've written here. You can also write this inequality this way. Okay, let's prove this formula. Prove this formula here. What I'm going to do is use this formula. No. I'll just use this. And I'll start thinking about the partial sums. Where was I? S, N. What is that? That is A plus AR plus AR squared plus, and I'm going to stop at the nth term. Now, it actually has the exponent n minus 1 because if you were to count these terms, you could say there's a 1 there, and you could say here I have 1, 2, 3, ... This is my n minus second term. This is my n minus first term, and then you can add one more term over here to get n terms. Okay, so this exponent has to be n minus 1. If you want your nth partial sum to be the sum of the first n terms. Okay, now I'm going to do some fancy footwork. I'm going to multiply both sides by what? By r. So what happens when you multiply this expression by r? We can think of every term shifting to the right. So this one gets multiplied by r, and I'm going to put it down here. So that guy kind of goes there, and this term goes there, when it gets multiplied by r. Okay, so I'm shifting them because I want to subtract. We'll see in a second. Okay, this term, when I multiply by r, gives me this term here. Okay, like I said, I want to subtract these two equations. So over here, when I subtract, I get Sn minus r Sn is equal to, well, when I subtract this, when I do this rectangle minus this rectangle, I get all kinds of cancellations, right? All these terms cancel. Leaving me with a minus that guy. ARN. So what's the point of all this? Well, I'm looking for this sum S, and I've seen before that's going to be the limit of Sn. That's what I'm motivated by here. Now I'm going to solve this equation down here. I'm going to solve it for Sn. So I factor out Sn from the left-hand side. And then I can solve for Sn. Is equal to S, it's an N, it's a W. Silly monkey. A minus A R N. Come on. Can't you draw a capital N? Still funny looking. Oh well. Tablet is not perfect. Okay. Nor is my handwriting. Okay, you may be asking yourself, what the hell are we doing such a complicated proof for? Well, we're going to need this equation later. Next chapter? I think next chapter I'll be using this one. Let's put a star on this. I'll come back to that later. Also, proofs are interesting. Now, what is the limit of Sn? Well, it's going to depend on what r is, right? If r, remember, n is going to infinity. Now, we talked about this before. Focusing your attention on this dude here, what is happening to that as n goes to infinity? Well, it depends on what r is, right? Let's say, first of all, that r is between minus 1 and 1. Maybe we'll put a big brace here. Well, if r is between minus 1 and 1, then this green circle goes to 0. Now, if r is actually bigger than 1, so r is, say, if r is bigger than 1, this green circle goes to infinity. So no dice, not working. If r is less than minus 1, also a big problem. And likewise, if r is equal to 1, or minus 1. If r is equal to 1, then we have division by 0. We have 0 over 0. Okay, so that's just not, does not exist. If we have minus 1, then the green circle is a divergent sequence. Okay, so that is our sum. Our sum is the limit of Sn. And that's actually the series. Plus AR squared plus dot dot dot. All right, pause and copy that if you haven't done so already. Then we'll do Zeno series. Zeno. What is Zeno? Zeno is summation n equals 1 to infinity. You know what? Forget that. Forget it. Zeno is 1 plus a half plus a quarter plus an eighth plus dot 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 dot. Or you can write that as a half to the 0 plus half to the 1 plus half squared plus half cubed. Now, the easiest way to use this formula, a over 1 minus r, is to notice that a is equal to first term. So this guy. 1. And r is this guy that has the exponent on it. Another way to find r is to take the second term and divide by the first term. So in this case, it's a half divided by 1, which is a half again. This is another useful way to find r. Now, the absolute value of r is less than 1. So, Zeno series, which is 1 plus a half plus a quarter plus dot dot dot, is a over 1 minus r. I can use the formula, which is, in our case, 1 over 1 minus a half, which is 1 divided by a half, which is, as expected, 2.